Welcome to Go Tutorials. You can watch our videos about education, tutorials, and more. And don't forget to subscribe, comment, and hit that notification bell for more updates. Our topic is about applying basic language, syntax, and layout by using the appropriate language syntax for sequential constructs. Presented by Group 6, Grade 12 ICT Computer Programming students. Our objective is to use standard sequential access algorithms for text and binary files. Code the standard sequential access algorithms for text and binary files. Brief introduction. A structured program was defined by D'Orazio 1990 as a computer program which is implemented using only those control structures which are found in structured program designs. Programming constructs programs are designed using common building blocks, known as programming constructs. These programming constructs form the basis for all programs. A program is a set of instructions that the computer executes. But if you did not get into details about the order, how would it be executed? This is where programming constructs came into action. They are used to control the order flow in which instructions are executed or not executed. In programming languages, the expression which translates to an instruction is called a programming statement or just a statement. Moving forward to our topic is all about technical terms. First is control structure, used to direct the program's flow for it's involved in every decision that an application must do. Second is program, is a set of instructions that the computer executes. Third is programming statement, is the expression which translates to an instruction in programming languages. And lastly is the sequential structure, the easiest control structure because it does not involve decision making. The program's flow depends on the step-by-step execution of it. First lines first, then proceed with the second is the mechanism of this structure. What is a control structure? Control structure is used to direct the program's flow for it's involved in every decision that an application must do. This logical structure pertains to a step-by-step execution of a program, also known as a straight line structure. This type of structure follows what is next in line for the flow of the program. Here's an example. Block 1 is processed first, and then block 2, and so on. Check the flowchart below so we can better understand its sequential structure. This sequence describes the specific order in which commands are written and executed. The computer does not read all of the steps and determine the correct order. The programmer has to determine the correct order, and the computer will perform the instructions one at a time in the order in which they are written. As you can see, before the program can output the answer, the first and the second number must be entered first. After inputting all the necessary values, the program can now start computing the sum and produce an output. Therefore, the program's flow is a step-by-step execution of the procedures that is synonymous to sequential conditions. Each algorithm has the same 5 steps, but in different order. In the second algorithm, the teeth would brush without toothpaste. The toothpaste would be put after brushing, then waste at its rinse away. A human might read all the steps and determine the correct order to complete them, but a computer will not. It will complete the steps in the order they are given. For this reason, the sequence of the steps is very important. A sequence construct tells the CPU or processor which statement is to be executed next. By default, in popular languages, this is the statement following the current statement or first statement in the program. In other words, this is the very basic construct of writing a program. You just write the line by line what you have in mind, of course, related to programming. A control is structure which determines the order in which instructions in algorithm are performed. The sequence control structure consists of processes which are carried out in a sequential manner.
You may have heard the term algorithm recently, whether it was online or maybe in some conversation about technology. It's a word that gets thrown around a lot, but what exactly does it mean? Well, simply put, an algorithm is a set of steps used to complete a specific task. They're the building blocks for programming, and they allow things like computers, smartphones, and websites to function and make decisions. But in addition to being used by technology, a lot of things we do on a daily basis are also similar to algorithms. Let's say you want to make some spaghetti. In order to do this successfully, there's a certain set of steps you need to follow in a particular order. First, you need to boil a pot of water. Once it's boiling, you then add the spaghetti and cook it for a set amount of time, stirring occasionally. Once it's finished, you drain the water and then it's ready to be served with a sauce of your choice. That entire process is actually an algorithm. Because you followed those steps in that order, you reached your desired outcome, a delicious pasta dish. But if you were to make a mistake, say over or undercooking your noodles, it probably wouldn't be as good. Programs work in a similar way. Their code is made up of algorithms telling them what to do. Let's say that we want to use a navigation app to get directions. When we punch in a destination, the app uses an algorithm to look at the various available routes. Next, it uses a different algorithm to check the current traffic. And then a third one takes that information and calculates the best available route. All of these algorithms are built right into the app's code. If there were any kind of error in that code, the app wouldn't be able to follow these algorithms correctly, meaning you wouldn't receive your directions. Both of these examples show how both humans and computers can use algorithms to perform everyday tasks. The difference is that computers can use algorithms and calculate things better, faster, and more efficiently than we can. Technology is only going to continue to evolve and get even better at what it does. As long as coding and programming continue to be used, algorithms will be at the heart of these technologies, guiding what they do and how they do it.
And don't forget to remember, sequential structure is the easiest to implement because it does not involve decision making. The program's flow depends on the step-by-step execution of it. First line first, then proceed with the second until the last line of the sequence. And that's it for this video. I hope you did learn something, and don't forget to subscribe.